Hello guys, welcome back to the second installment of our salicylic acid saga. Today we'll be making benzoxazolinone from salicylamide via a variation of the Hoffman rearrangement. First, we weigh out 3.4 grams of salicylamide and add 100 milliliters of water. Next, we prepare a cold ice bath and add some salt. We put our first beaker containing the salicylamide into the ice bath and cool it down. Then we measure out 3 grams of sodium hydroxide, add 50 milliliters of water and 13 milliliters of 4% sodium hypochlorite. When the salicylamide slurry has cooled down below 7 degrees Celsius, we start adding the sodium hydroxide hypochlorite mix in 5 milliliter increments. Temperature control is important and we don't want to go above 10 degrees Celsius. After the second addition, we can see a slight color change to a light yellow, and after the final addition, we're left with an emerald solution. Next, we prepare a solution containing 1.5 grams of sodium hydroxide and 15 milliliters of water. We remove our beaker from the ice bath and set up for heating. Add the previously prepared sodium hydroxide solution and heat it up to 80 degrees Celsius. We leave it on the hot plate for half an hour. After the 30 minutes have passed, we can see another color change from green back to light yellow. We can take the beaker out of the hot plate and cool it down until the temperature falls under 10 degrees. Measure out 25 milliliters of 30% hydrochloric acid and add it to the beaker. We can see benzoxazolinone dropping out of solution. After adding all of the HCl, we get a fluffy white precipitate. When filtering it, I noticed an interesting property. It smelled like a mix of chlorine and bacon or some sort of other burnt meat, although it did have a bit more of a chemical smell. After filtering, washing and drying, we got a mere 1.38 grams, which is a 41% yield. Doing a melting point test proved to be difficult because the product started to sublime when heated above about 120 degrees. Everything did melt when the temperature hit 130 to about 132 degrees, which is approximately 5 degrees off the literature value of 137. But again, because of the sublimation and the crappy technique, my melting point wasn't measured perfectly. After repeating the reaction, I got 2.73 grams, which is an 82% yield, almost double what we got in the first batch. In the second run, I held the temperature under 5 degrees, added the hypochlorite hydroxide mix 4 milliliters at a time, heated the mix up for 45 minutes instead of 30, and on the final cooling, cooled it down to 5 degrees instead of 10. The final product looked almost exactly the same as the first batch, but it was just a tiny bit more tan in color. Thanks for watching and tune in next time.